2022 Exam 1 NHT. So you can see with the first question, very easy. Bridge is that part right there, so P to Q is the answer for that one. For the next one, a bar pie type graph is the most suitable one because if we've got drivers to stores, okay, if we try to allocate those particular people, we need to use a bar pie type graph. Next question 3 talks about a Eulerian trail. Alright, so when we're talking about the Eulerian trails, we're talking about all edges are connected, but necessarily more or less the 2 odd degrees. In this case, we've got 3. Reason being is because we've got 2, 3, 2, 3, 2. Yeah. We've got 2, 2, 3, 1. Okay, that's yeah. And this one here has got 2, 3, 3, 3, 3. No, that's not. This one here is 2, 2, 2, 2. We did say that it has 2 odd degrees, but we also have to remember that a Eulerian circuit is also a trail. Not trail, it's trail. So that means this one is also part of that. Question 4. This talks about minimum spanning length. In this case, if we go through a particular set, let's use perhaps Prim's algorithm. In this case, if we have 10 and if we're trying to connect the next one from this point, all these other ones that join to F, 13 is the smallest one. If we look at node B, the smallest one that joins to node B is that 13. And in this case H, that's probably the only one, or we could even use that one if need be. I'm going to use the top one just for symmetrical purposes. Node I, the one that joins node I is 10. Now if we look at the rest of these, that one has to go up there. D and E have to be joined by that way. If we're going to join and connect this graph, there's really no other option apart from either ID or FE. In this case, let's choose ID. In this case, if we add it all up, we get an answer of 107. Alright, now the next one, question 5, talks about which path is suitable in this case. Now, this one here is a little bit tricky because you've got to be aware of that particular path, that's not a node, so there is a loop that goes from B to B. If that's the case, B to B means that this one here cannot be the answer. Let's look at the other ones as well. I can see with this one is A. There's no loop that goes back to A, so that's not the correct answer. And this will also not be the correct answer. So I'm going to focus on B to C. Now there's 2 ways to get to B to C. There's that way, and there's that way. So if I look at these questions here, there is only one way to get to B to C in this case, where you've got 2 to go from here to here, which means C is the correct answer for this one. Now question 6 requires the Hungarian algorithm, and if we go through row reduction, we're going to have to subtract 5 from the top, subtract 4, subtract 5, subtract 6, and subtract 4. And I trust that you'll be able to do the algorithm. So we end up with C, E, B, D, A as our solution. We only need to go through one pass, so our answer is A. So in this case, it's not true because Amita will complete her allocated task after Boris. Alright, maximum flow in this network is 35 litres per minute. So thankfully, if we look at this cut, we get 14 plus 13 plus 8, and we get a total of 35. So this is the maximum flow, which is the minimum cut in this case, which means that any other cut that we do in this particular path has to be less than 35. Now, if we make a cut going through this way, you can see 10 plus 8 plus 12 plus x. This gives us a total of 20, 30 plus x. Okay, that has to be that has to be greater than 35. Now, the reason why it has to be greater than 35 is that because the maximum cut is the maximum flow is the minimum cut. So in this case, since we know that 35, this is the correct answer, everything else has to be larger than the min cut. So in this case, x has to be greater than 5. And in this option, if we look at all the options here, we get x, x, and x. These are all 4, 4, 4. Those are incorrect. So let's look at another situation here where we have perhaps maybe, let's see, 8xy, this. Let's look at this cut here. And if we look at this cut, we get 8 plus w plus x plus y plus 6. That has to be less than or greater than or equal to 35. Now, if we look at these two options, thankfully this question was made in a way that both x and x values in this case were 6 after you go through the process of elimination. So if we put 6 into here, we'll get w plus y has to be greater or equal to then 20, so that's 15. Now, w plus y is equal to greater than 15 when you get this situation here with c. You can see with a, it only equals 14, which means that it's not sufficient enough to actually satisfy the requirement. Alright, now question 8. Question 8 will require you to actually draw this out multiple times because it does get quite tricky. Now, with this particular diagram, I would highly suggest that you do this one last after you've finished all the other modules because this one can really take a bit of redrawing. So let's start off with the first branch that I've got here. So A, B, and C. Now the reason why I can say that is because there's no immediate predecessors. Alright, so D has an immediate predecessor of A. So I can assume, in this case, I'm actually going to draw this the other way around. I'm not sure why I drew it this way. A, B, C. D has immediate predecessor of A, which means that D goes here. Now, we've done this. Now, E has a predecessor of B and F. Now, in order for E to start, it means that B and F need to be completed. So E is here and F needs to be completed. But F in this case is a predecessor of C. But since there's no connection between the two, F goes there, and therefore there'll need to be a connection that goes from here to here in order for E to have that to satisfy that immediate predecessor condition. So we've done the F. Now G also has a predecessor of C in this case. I'll write that down. Okay, now from here let's look at H. H has a predecessor of D and E. So D and E, okay, so H is a predecessor of D and E. So H will need to be some sort of path here. And for now, we can look at I being this one here, and since since J has particular predecessors, what we can do is we can call this J, and we're going to leave this line like this at the moment. So H has D and E as predecessors. Now, it comes down to this question with what do we do with this E block right here, because the predecessor of H is E, but also the predecessor of H is E. Now, this indicates to me that there is no solid line that joins this particular case, because what would happen is that if this was fully joined like a line, actually I should probably draw it like this. If this was straight out drawn E like this, and we create the dummy variable in this particular way, okay, this would imply that H has a predecessor also of I, because H can't start until D, E, and I are complete. Well, we know that since that is not in the information, we also know that this is not the case as well, where we have E directly connecting to this node, because we would also need to create some sort of predecessor dummy for this instance as well, because in order for J to start, it needs G, I, E, but not D. So since we don't want D to be complete in this particular section here, we know that this, in fact, is a dummy variable going that way and dummy variable going that way. And so since E is a predecessor of both H and J, but not the corresponding branches, we can leave it. We can say that there's 3 dummy variables that are required for this particular question. This is a very tough question.